data classification. Now in the last section 1.1 we learned that there are two types of data, the quantitative data and the qualitative data. So remember, the qualitative data is the one that consists of labels and names or descriptions of traits, and the quantitative data is counts and measures. Now the quantitative data can further be divided into two categories, continuous or discrete. So the continuous data are quantitative data that can take on any value in a given interval and are usually measurements. So if the values will lie in some interval, then we say they are continuous data. Discrete data are quantitative data that can take on particular values and are usually counts. Looking at this example, classify that following data as either qualitative or quantitative. Shades of red paint in a home improvement store. So what do you think? Shades will be like light red, dark red, crimson. There are different shades. So what are these? Names, labels. So this will be qualitative. The next, amount of red primary dye necessary to make 1 gallon of each shade of the paint, red paint. So this will, because we are talking about amount is a measurement, so this will be a quantitative. Okay, next, rankings of the most popular paint colors for the season. So rankings, remember, are labels. So this means this is qualitative. And again, number 4 is saying numbers of paint choices available. Let's have this. So number means counts. So this is quantitative. So this is how you should be able to figure out the difference. Next example, determine whether the following data are continuous or discrete and explain why. Temperatures in Fahrenheit of cities in South Carolina. Well, it could be any city or any place. Now temperature, what is it? Is it like a measurement or is it just like counts? It's a measurement, yeah. So it is continuous. So you can think about maybe, like, for example, in Michigan, you can say the temperature mostly lies between, like, let's say, I don't know, let's talk about Detroit. So like between minus 40 and 40 degree Fahrenheit to maybe 105 degree or maximum 110 degree. Well, you can put any limit, you can even go to infinity. The temperature lies, the lowest temperature that can ever happen in the world is what we say 0 Kelvin, and I believe 0 Kelvin is like negative 320 degrees Celsius, which is very, very low. So anyhow, that is called absolute zero. The zero of the Celsius is not the same as the zero of the Fahrenheit. Remember, so because these are kind of place values. These are zero is treated like any other data value. Okay, next is numbers of houses in various neighborhoods in a city. Well, it's numbers, so it's counts, so it will be discrete. Numbers of elliptical machines in every YMCA in your state, so this will also be discrete. Now the floor, the heights of the doors, this will be continuous because heights can be between maybe like 7 feet 6 inches to, I don't know, maybe like 20 feet high. The next thing is level of measurements. So sometimes we can look at data in this way. So one way of looking at it is whether it is quantitative, qualitative, and then if it is quantitative, whether it is continuous or discrete. Another way of looking at data is by the level of measurement. So what does that mean? It means we want to categorize the data so that they indicate the type of arithmetic that is appropriate for the data, such as or ordering or taking differences or taking ratios. So these four levels, nominal, ordinal, interval, and ratio. So this is the lowest level of data, and this is the highest or the highest level of data. Okay. So anything below, like they are going in upward order. So lowest to highest. Okay, so what is the nominal level of measurement? It applies to the data that consists of names, labels, or categories. There are no implied criteria by which the data can be ordered from smallest to largest. So anyone can have their own choice how they want to arrange it. If it can be arranged enough, then it will be. Actually, I mean, it will be like not clear for everyone. Everyone can have their own choice. Okay, let's see. Next one is the, by the way, and this is the qualitative type of data. So the qualitative data can be divided into two categories, nominal or ordinal. What is the ordinal level measurement? It applies to data that can be arranged in order. So this is the big difference between ordinal and nominal, that the nominal level is qualitative data, but it cannot be arranged in order. But ordinal level of measurement is still qualitative data, but it can be arranged in order. And that's all, we have. So if you take the difference between values, then it won't make any sense. It will be meaningless. So for example, if you look at the numbers on the jerseys of any football players, so the numbers can be arranged in order, but if you subtract the numbers, that the difference is not giving you anything, like meaningless. So this is called the ordinal level of measurement. Third is the interval level. So these two are for the qualitative, and now these two will be for the quantitative data. So this interval level of measurement applies to data that can be arranged in order. So it is kind of same thing that we saw in the ordinal level. But what else is included in here? In addition, differences between data values are meaningful. So data where differences are meaningful, and it can be arranged. That is the first thing. It can be arranged in order. I will explain a little bit more, but let's look at the next definition, the ratio level. So it applies again. It has to be. We should be able to arrange it, and the differences should make sense. Now, differences between data values should make sense, and also ratio between data values should make sense. So for example, if you are talking about the age of someone, so then if you have someone 20 years old and then another person 15-year-old, so if you take the difference in the values, you have something meaningful. What is that meaningful thing? That this person A is older than 5 years older than person B, or person B is 5 years younger than person A. So the difference has some meaning. What about ratio? If we divide 20 by 15, we'll end up getting what? 4/3? What is that indicating? Basically, it's indicating that the elder person age is 4/3 of the younger person's age. It's 4/3 of the younger person's age. So ratio also makes sense. Another thing that we should be able to talk about in ratio and interval level is the zero. Okay, let's see examples of interval level variable include temperature in Fahrenheit or in centigrade. The pH value, I hope you guys know what is a pH value. This is a kind of a value, acidic value of water or any liquid. SAT score, which are usually given as like a range, 200 to 800. Credit score, this could be number between this. So these are, can you see, these are like these live in an interval, so that's why it's called interval level. Now a ratio variable has all the properties of an interval variable and also has a clear definition of zero or 0.0, you can say. When the variable equals 0.0, there is none of that variable. So it means we don't have, it means that the variable is, the thing is not there. Okay? So examples of ratio variable or ratio level of variable include dose amount, like medicine, reaction rate, flow rate, concentration, pulse, weight, length, temperature in Kelvin. Notice here, this is the big difference here. Kelvin, and here we were talking about temperature in Fahrenheit and Celsius. So the temperature in Fahrenheit and Celsius means, the data is interval level, because we can bound it in an interval. But in the Kelvin case, zero means like literally zero temperature, like nothing can survive. There are many things which can survive in very, very low temperatures, minus 100 degrees centigrade, minus 200 degrees centigrade. But in the Kelvin scale, 0 degree Kelvin, nothing can survive. Okay? So there is no heat. Okay. Next example. It says the following statement describes different data associated with the state senator, indicate the level of measurements for each data entry. So we have to basically talk about those 4 levels. That senator's name is Sam Wilson. Now it's a name. What are names? Names are nominal level. Okay, the senator is 58 years old. So what is that? Then if the senator is 58 years old, it means we are talking about ratio, because we just saw in here so it didn't mention the age, but dose amount, reaction rate, flow rate, weight, length, age, so, and I gave you the example. So this is the ratio level. The difference makes sense and the ratio makes sense. C is the years in which the senator was elected to the Senate are 1998, 2004, and 2010. So what type of data is that? Well, these are numbers, so, and they can be arranged in order. So is it ordinal data? Well, it could be, but let's now go to the next step, means check the difference. Does the difference between these values or years, does the difference have some meaning, or is it meaningless? Well, what we get when we subtract, for example, 204, we subtracted from 2010, we get what? 6. So what does that mean? What does it tell us? It tells us that the senator was in the Senate for 6 years, so it makes sense. That's why we say this will be interval level. Okay. The next is the senator's total taxable income in 2014 was $878,314. Okay, so this is one value, but if you had some other values or his data for his income for some other years, we could arrange them in order, and difference between them will make sense. It will tell us that between these years, has been this much change in his income. It has maybe decreased or maybe increased, whatever. And then also, if we take the ratio, it tells us the fractional part of how much the senator's income has increased. So this is the income is going to be a ratio level of data. Next is the senator surveyed his constituents regarding his proposed water protection bill. The choices for response are strongly support, neutral, against, or strongly against. What is that? These are again labels or names or descriptions. So this is the qualitative data, but it can be arranged in an order, right? In some order. So this is ordinal data. F, the senator's marital status is married. Okay, so what's that then? That will be this will be nominal. Next is saying, this leading news magazine claims the senator is ranked 7th for his voting record on bills regarding public education. So it's a ranking. Ranking is a qualitative data, but ranking is something which can be arranged in order. So this is ordinal. Okay, let me stop here, and rest of the examples in the next video.